Hi NTHP aspirants for IBA-Karachi, it's Math with AUB. Let's get along. Selection from the past papers of Sat Parna, and the first question is from German Olympiad. It reads as X, it's question number 1, x minus negative x negative 2 is equal to negative 12 times x plus 1 raised to 99 divided by minus x minus 1 raised 100. Solve for x. Solve for x. Don't go here and there. If the powers are 99 and 100, you must be pretty sure that there is no case of expanding these two terms. Expanding these two terms. The cumbersome, the longer it resembles, it looks in appearance, simpler is the solution. Simpler is the solution. Look at this. If we take minus common from this, it will become x plus 1. It will become x plus 1. It's also x plus 1. They are cancelled out, and we have a tiny sort of question in power 2 means quadratic. Taking negative common from this, the longer, the greater, the cumbersome in appearance, just crack a single brick, take out a single brick, then the building is going to collapse of this question like this negative 12 x plus 1 raised 99. Look at this negative common. Whenever we take negative common or negative 1, what remains? The change the symbols of all these terms. If we are taking negative common, raised 100. Now look at this. Overall power is even. Overall power is even. This negative will be turned to positive owing to the power 100. If we multiply negative into negative 100 times, it results in positive. It results in positive owing to the power even. Owing to the power even. So we have negative x negative 2 is equal to negative 12 x plus 1 raised to 99. It turned to be positive. No need to write. X plus 1 raised 100. Look at this. Cancelled out. Here remains only x plus 1 raised 1 in the denominator. So we have negative x minus 2 is equal to negative 12 divided by x plus 1. Shift x plus 1 from division to multiplication from right to left. We have something like x minus 2 times x plus 1 is equal to negative 12. Just simply multiply. It will become negative x square. Negative x times 1 is negative x. Negative 2 times x negative 2x. Negative 2 times 1 is negative 1. And we have minus 12. Shift this minus 12 here. It will become minus x square. These are like terms. Negative x, negative 2x. It will become negative 3x. And here it is minus 2 into 1. It will become minus 2. Minus 2 into positive 1. It is minus 2. So we have minus 2 plus 12 is equal to 0. Negative 2 plus 12, negative 2 plus 12, we have negative x square, negative 3x plus 10, a tiny trinomial type middle term breakup, or you can apply quadratic in that case. We have something like negative x square, negative 3x, negative 10 is equal to 0. I have written incomplete. 2 5 the 10. 2 5 the 10. There is 1 times 10 is 10. 1 times 10 is 10. 10 can be factorized into 2 into 5. If I write negative 5x plus 2x, negative 5x plus 2x, I will get negative 3. From the coefficient of x square and the last term constant, I have managed the middle term. So, middle term can be written as negative 5x plus 2x plus 10 is equal to 0. Look at this, negative 5x plus 2x, we are going to have again negative 3x. Taking negative x common, we are left with x plus 5. Taking positive 2 common, we have x plus 5. These two brackets are identical. We are wonderful with middle term breakup. x plus 5 times negative x plus 2 is equal to 0. Either or x plus 5 is equal to 0. So we have x is equal to minus 5. And it is negative x plus 2 is equal to 0, or negative x is equal to negative 2. Multiply and negative, both sides are negative, negative cancel. We have x is equal to 2. So in that case, x is equal to or x is equal to minus 5. The key to solve this question is take negative common, take negative common. Taking negative common or minus 1 common is a wonderful thing in mathematics. Is a wonderful thing in mathematics. It's a minute step, almost ignorable, but it works wonder. Taking minus common shows the maturity of a mathematics solver, a mathematician. If you are going to take minus common, it's a fine thing, it's a very slim thing, it's a very fine thing, it's a very delicate thing, but a wonderful thing to me. Okay, moving towards question number 2. It states that, it reads that during a trip, Jonathan had driven a total of 75 miles by 20 past 6 p.m. By 20 past 6 p.m. and a total of 85 miles by 40 past 6. 40 past 6 are 20 to 7. He drove at the same rate for the entire trip. At what time had he driven 140 miles? 140 miles. During a trip, Jonathan had driven a total of 75 miles by 6:20 p.m. Up till here, we have given nothing except the time. By 20 past 6, he has traveled 75 miles. We are almost blank, surprised. We have nothing to deal with, to negotiate, to find another thing. This distance, velocity, just a googly type. First line. Second line works wonder. And a total of 85 miles by 640. From this, we can do something. 75 miles by 20 past 6 and 85 miles by 640. Then we are in a position, he traveled 10 miles. Difference of 85 and 75 is 10. He drove 10 miles in 20 minutes. The difference of 20 past 6 and the difference of 40 past 6 is 20 minutes. In 20 minutes, he drove 10 miles. Now we are in a position to find the rate, then apply it to the rest of the problem. Then we are in a position to find total time. He has driven 85 miles, 75 miles by the time 20 past 6 p.m. 85 miles by 40 past 6 p.m. Look at this. From this tiny line, we can get through in this question. It's a key to this question. Now 85 minus 75, 10 miles. And the difference of time is only 20 minutes. Its distance, its time. Now we can calculate the speed at which he is driving. Formula is given by distance is equal to speed times time. Distance is 10 in that case. Speed we are interested in. Time is 20. Shifting 20 from multiplication to division, we have our speed is 0.5 miles per minute. 25 miles per minute. Okay. At this rate, he had driven 140 miles. 140 miles. Now look, up till 40 past 6, he has traveled 85 miles. The rest 140 minus 85. It will become 5. It will become 313 minus 13 minus 8. We are interested in 5. 55 miles more he has to travel in how many minutes? In how many minutes? Now, by 20 past 6, he has traveled 75 miles. By 40 past 6, he has traveled 85 miles. Then he said that at this constant rate, throughout, he traveled 140 miles. He has covered 75 by 20 past 6, 85 by 40 past 6. The next 15 plus 50, we have 15 plus 40. If we add 15 to this, 140, 55. 55 miles he has to cover still. Still he has to cover 55 miles in how many minutes? Then we have to add this time in this timing. Let's see and find out the remaining journey comprises 55 miles. We have speed 0.5 miles per minute. Applying same formula, distance is equal to speed times time. Speed times time. Distance is, we are interested to cover still 55 miles. Our speed is 0.5. Our time we are interested in. Shift 0.5 here from multiplication to division. We have something like 55 divided by 0.5. That's our time. Dividing this, remove this decimal, introduce 1 with 0, it will become, I think, 11 times. 11 into 10, it will become 110. So our time is 110 minutes. 110 minutes. 110 minutes means 1 hour, 1 hour and 60 plus 50 minutes. 1 hour plus 50 minutes. 1 hour plus 50 minutes. He has traveled the remaining 55 miles in 1 hour and 50 minutes or 110 minutes lump sum together. How to add in the time? Let's see and find out. Up till 40 past 6 we have traveled 85 miles. The timing is 6:40. If I add 1 hour in this, it will become 7:40. 40 past 7. Still I have 50 minutes. Still I have 50 minutes. Still I have 50 minutes. If I add 20 more in this, it will become 8. 8. If I add 20 minutes from this, it will become 8. Still 30 minutes are remaining. 30 minutes are remaining. So our time is half past 8. At half past 8, Jonathan in a position to travel 140 miles at the rate of 0.5 miles per minute. At the rate of 0.5 miles per minute in that case. Moving towards next question, the function defined by f of x is equal to x square plus bx plus c, where b and c are the constants, where b and c are the constants. If the graph of the function has x-intercept set -5 and 3, which of the following correctly gives the values of b and c? We have a graph equation that is only x square, coefficient having 1, plus bx plus c, and having x-intercepts equal to, means values of x -5 and 3. Then determine the value of b as well as c. Sorry, these are the both values of x-intercept. Look at this. It is the other way around of solving. If we have given a quadratic equation whose roots are -5 and 3, find the required function or equation. That is the formation rule for a quadratic function. Formation rule for quadratic function. It is f of x is equal to x square negative times sum x plus product. Negative times sum is equal to product. In that case, find the sum of the roots. We have x1 minus 5. Suppose x2 is equal to 3. Find their sum. X1 plus x2 minus 5 plus 3. We have x1 plus x2 is equal to minus 2. And the product x1 into x2 minus 5 times 3, it is minus 15. So we have x square value of sum is minus 2, x product is minus 15. We have x square minus 2x minus 15, or one can write x square plus 2x minus 15, x square minus plus 2x minus 15. Now compare this here. From this we can infer that value of b is 2. Value of b is 2 while c is equal to minus 15. While c is equal to minus 15, where lies the option? I think D is the correct option in that case. Let me reconcile that. X square minus plus 2x. If I compare with this, that is the situation. From here I have to compare. Then this is the value of b, this is value of c. So I have b is equal to minus 2 and c is equal to minus 15. B is equal to minus 2 and c is equal to minus 15. If I insert both of these, then I arrive here and I can verify as well. X square minus 2x and it is minus 15. Okay, we are going to verify. If we are going to get the values of roots minus 5 and 3, then we are correct, otherwise we are not. Let's see and verify. We have x square minus 2x minus 15 is equal to 0. 5 3 is the 15. If I write this one as negative 5x plus 3 minus 15 is equal to 0. Taking x common, x minus 5 plus 3 common, we have x minus 5 is equal to 0. One bracket is x minus 5, other is x plus 3. We are going to get x is equal to 5 and x is equal to minus 3. Reverse is the symbol in that case. Reverse is the symbol in that case, or b is minus 3 and c is 15. B is minus 3, C is going to be 15. What are the roots given in that case? Minus 5 and 3. Minus 5 and 3. So that is not the case. Value of B is going to be the positive one. Value of B is going to be the positive one. Let's see and find out. X square plus 2x minus 15 is equal to 0. Now again 5 3 is the 15. X square plus 5x minus 3x minus 15 is equal to 0. X common, x plus 5 minus 3 common, x plus 5 is equal to 0. So we have x minus 3 and x plus 5 is equal to 0. So in that case x minus 3 is equal to 0, x is equal to 3 and x plus 5 is equal to 0, x is equal to minus 5, x is equal to minus 5. So this tallies with the question x is equal to minus 5 and x is equal to minus 3. These are the x-intercept of the given function. X-intercepts of the given function. So value of b is 2, value of b is 2 and value of c is minus 15. Value of b is 2 and value of c is minus 15. D is the right option in that case. B is the right option in that case. Verification is the best strategy in that case. X square plus bx plus c. We are interested in b and c. We have given x and y intercept. Another way around of doing this question, let me try this as well. or one can attempt in that fashion a return method. We have x is equal to minus 5 and 3. Put x is equal to minus 5. It will become 0. Minus 5 square. B times minus 5 plus c. We have, it will become 25 minus 5b plus c is equal to 0, or minus 5b plus c is equal to negative 25. It's our equation number 1. Put x is equal to 3 in that case. We have 3 square plus b times 3 plus c is equal to 0, or we have 3b plus c is equal to minus 9. Minus 9. That's our equation 2. Solve 1 and 2. Minus 5 plus b minus 5b plus c is equal to minus 25. Sorry. And 3b plus c is equal to minus 9. If we subtract, cc cancel out, we have negative 8b minus 25 plus 9, it will become minus 16. So that is the ample proof b is equal to put in any equation to get c. That's the simple one. Let me insert here. Let me plug in here 3b plus c, 3b plus c, pass me the marker, 3b plus c is equal to 9, negative 9. 3 value of b is 2 plus c minus 9. 6 plus c is equal to minus 9. So c is equal to minus 9 minus 6. So c is equal to minus 5. Yes, b is equal to 2 and c is equal to minus 5. Minus 15 are the right option in that case. One can add up whatever one can wants. Either to apply formation of quadratic function x square minus sum of the roots plus product, or directly verify its our f of x means 0. We have x intercept. X intercept means f of x 0, f of x means y. X intercept means y0, put f of x 0 instead of x minus 5, we have equation 1. Similarly, put x is equal to 3. In that case, it will become 9 plus 3b plus c, and it's 0. We have second equation. Solve 1 and 2. Solve 1 and 2. Moving towards final question. It states that in the xy plane, the line y is equal to mx plus b, where m and b are the constant, is a reflection of a line across the y-axis. At which of the following point do the lines intersect? This is x-axis, sorry, y-axis, this is x-axis. Draw any line that, suppose it's my, this is our y-intercept, that's our 0b, that's our x-intercept, suppose it is on the left hand side, it is a negative. Draw its reflection. Its reflection will be like this. Here it is a0 and y-intercept remains same. Y-intercept remains the same. Reflection in y-axis, they are almost identical except changing the symbol. Y-axis works as a mirror. Y-axis works as a mirror. Y-axis works as a line of symmetry. Y-axis works as a line of symmetry. So reflection of minus a0 is going to be a0. Here negative way, here it is positive way. We consider the distance. There lies at the equidistant. And in the same token, y-intercept remains same. Y-intercept remains same. So they intersect at 0b. Or one can draw another possibility. Here we have this. Suppose b itself negative. Here it's 0b, and here it's a comma 0. Find its reflection according to y. It seems to be like this. Here again we have negative a0. We will get the same y-intercept in that case, and both the lines meet at 0 comma b. So in that case, if one line is a reflection of another line in y-axis, their meeting point is their y-intercept. Their meeting point, their point of intersection is y-intercept in both cases. Whether they intersect in positive y-axis, whether they intersect in negative y-axis. It's my any effort you guys explain to you how to prepare for the exams or how to attempt question. It's all about itself next.